up of 3 different teams we have there. We have the ATS development team that's here. We also have the Brooklyn development team. Brooklyn is our global DNS load balancing team. And then we have the Edge Analytics team. And so there's some relations with all 3 of the teams. And so one of the things that the Edge Analytics team does is they do a lot of interesting analytics based off of ATS logs. So with the summit here, I figured it'd be interesting rather than having one of the analytics team come here that I can kind of speak on it for the analytics team. So this is analytics that we do using ATS logs and some other kind of enhancements to enhance the data there. And I'll kind of cover that. So the agenda of the talk, I'm going to go ahead and cover why we wanted to do this, and then kind of get into kind of how we put this together, and then how what we kind of made with using the data from the ATS logs, and then kind of the results that we're seeing from that. So starting with why. So initially, they decided, let's go ahead and can we create and do some internet mapping. We want to find out how well our CDN is running. Are our clients doing well? Are we serving our clients well? Are they having low RTTs? And is the user experience good? So we decided, can we actually do some internet mapping? And the other questions we're asking is, okay, are there areas of the network we can look into to find out are there problems? Are there transit issues? Or are some of the problems that our clients seeing, are they last mile issues that we can't really deal with? I mentioned the Brooklyn team that does the global DNS load balancing. Are we seeing issues with that? Are there load balancing issues that if we have clients on one POP versus another, do we see better performance? And then also we can look at capacity planning. If we look at different areas and we can say, would it be better if we had a POP in this particular country or area of the country as well? But we want to provide insight as well. Other teams, networking teams and so forth within the organization, and then management as well can be very useful for providing insight into how well our CDN is doing. So getting into how we built the analytics, first thing we decided to do is they hired a data scientist. They figured let's go ahead and get a person in here, start collecting this data. Once he got on the team, he started looking at what data we have, what data we're collecting, do we have anything we can start using right now? He realized that we don't have the data right now that we wanted. And so he looked at what are the data sets that are out there available, how can we collect this data and utilize it? And so these are some of the logs he first started looking at. Of course, ATS logs, can we use ATS logs? Can we actually measure server-side measurements on the servers, the POP servers? DNS logs, can we collect those? He wanted BGP data. He originally was kind of targeting this for using BGP data, but I'll kind of get into that since that's still an ongoing thing we're trying to do. And then do we have geodata that we can kind of enhance what we're seeing as well? So once he got an idea of the data sets that he wanted, request the resources on what we call our grid. And so we have a Hadoop clusters, and we have all of one of the nice things at Yahoo is that we actually have the teams that we can actually drop all this data on Hadoop. We have all the tools there, Spark, Storm, and so forth that we can utilize. And then of course, the question we can ask is, well, why don't we just use Splunk for all this as well? So he kind of looked into that. One of the things is actually looking at Splunk as so it's good for what it's built for, but when we started thinking about how this was going to scale, when we started determining how many logs that we had, what kind of analysis we're going to do, we realized it's really not going to be good for what we wanted to do. It is good for aggregating, it's not good for aggregating data, it could take a long time. The other thing we realized, if we wanted to do this on Splunk, it could cost a lot of money because we had a lot of data we wanted to collect. So Splunk is used by our ops team. So the logs that we're collecting and utilizing for analytics, the ops team is dumping into Splunk as well. I talked to them. They primarily use it for troubleshooting. It's like they said, it's good for doing their quick time analysis. What's going on in the network right now. Can I go ahead and set up a query and start generating logs? And then also the analytics that we're doing is primarily based on access logs. And when I talk to the ops teams, they are using the diags, traffic out, error logs. That's their best information sometimes for debugging things and seeing what's going on. We collect some of these logs as well, but they're not utilized within our analytics stuff as much. We do produce some of the analytics for the ATS teams that they can look at, but a lot of the main customer for us is like a networking team and paranoids and so forth. When we first started looking at this, the data scientist, he found a paper that Google came out with, and they had a project that they had in there that they called Weihai. And that was doing some measurement of their CDN performance and how can they optimize their CDN. And they kind of laid out these 3 steps to be able to diagnose poor RTTs experienced by their clients. Can they identify the prefixes that are affected by the inefficient routing? Can they prioritize this so that actually people can start looking into this and finding out, okay, why is this problem happening? And then can they actually diagnose the causes for the identified problems? Can they actually fix this? And so we kind of he took this and decided, okay, how can I utilize these same ideas in generating, doing analytics for the data that we had. So here's what we ended up building with it. So we basically were collecting all ATS logs from the edge machine. So all the logs come in, we're collecting those. This is kind of a quick snapshot for some documentation of all the components of that. But for the most part, the ones that we're really looking at is IP address, port of client, some of these things, SSL version used, some of the response codes are helpful for the ATS teams, or debugging. We got colo information, fully qualified domain name, we get browser versions. And so one of the team here was debugging something. Vineeth was looking at this recently. I just put this in here. And he was doing some looking at the logs, and he determined that the average log length that we're seeing is around 800 bytes. So that's the average. We have some small ones. We have some much larger ones, as some of these URLs can get really long. Okay, so then we also want to do server-side measurements. So in order to do that, we needed to find an accurate RTT measurement that we can get on the server side. And so when the data analyst started looking at this, he realized there is one in TCP info, but it's really not, well, actually there's one right now that's not exposed to TCP info. But the one currently used in TCP info, he realized, okay, this is not what he wants. It's basically using an estimated rolling average. It's used for this congestion control algorithms that were in there. And I think he said when he actually looked in the source code, it said, do not use this for an accurate measurement of RTT. So eventually, I think in later versions of Red Hat, some of that measurement, it will be exposed. We won't have to utilize the script. So Brian had a collection, a script that he wrote, a basic piece of code that does, we call it the system tap collector. It collects the round trip times. Brian want to mention that this also includes the delay X in there. And so this basically does it on the server side of what we're seeing for RTTs, so with our clients.
Sorry.
Yep.
It doesn't include it.
It doesn't.
It doesn't include, the other one includes the that's why the one of the kernel.
Oh, I thought you said, got it mixed up the last time you did it.
Yeah,
okay.
No
Gotcha. Okay. We also collected DNS logs. Everybody's familiar with DNS logs. I don't have to say much about that. We wanted geodata. Can we actually put geodata on top of the IP addresses and find out where these locations are? We do have a geodata team within Yahoo, Verizon Media. They actually have two commercial packages they utilize. So they use Data Envoy and MaxMind, and they combine that with some other internal measurements that they do from other teams, Flurry and stuff like this. They create a geodata pack, and then within this geodata pack, they have information. They have kind of a confidence factor based on IP. So if they match up with both commercial packages and what they're seeing, confidence is high. In other times, it's like, okay, in certain areas, it's like the confidence is really low as to actually, is this the actual location? So we enhance data with the geodata pack. So now we basically take all of these logs, combine them as a kind of, as we collect them, and then put a copy on the Hadoop cluster. So basically we have the map reduce job, takes these things, combines them, all the information, dumps it on the Hadoop cluster, and then we can run some analytics on that. And as well as we have a Druid cluster that I'll kind of mention as well, we dump the data into Druid. Okay, so from all this data we're collecting in there, we decided to create our own Weihai report. And when we started looking at collecting it, as we collected the data and started looking at the way Google did this, they were doing it by country, like I said, country, state, city for clustering. The scientist was kind of looking at that and realized it's not going to be an accurate measurement of what we wanted. So he kind of created his own clustering algorithm that basically generates it by the type of connectivity and the locale of where it's at. So within larger cities, you may see a lot of smaller clusters of these geo clusters that he has, and as it spreads out, you can kind of increase the size of the geo clusters, and pretty much now you're getting a better and more accurate measurement of the similar type of network access and connectivity that you would see within these regions. And there's actually, he has a couple different ways of looking at this. He has a way of aggregating in a small area or kind of more of a larger area as well. So then once we had these together, we went ahead and created these, we broke down reports based on IPv4, IPv6, and then we have mobile reports. We can look at property usage. We have a 50 millisecond report, so now we know certain areas. If we see clients that are above 50 milliseconds, we can go ahead and start reporting on that, so we can then go ahead and target some of those, some of the worst RTTs that we're seeing, some of the worst clients that we see out there. We do correct stuff with ASNs, based on all the different ASNs, what are we seeing for different ASNs. And then also I mentioned we dump the data into the Druid cluster, so we use a tool called Pivot as a front end on top of the Druid cluster, and that allows deep dives into the data. And then I'll kind of get into the reports. So one of the things that we do is once we generate all these reports, the analytics team, we meet with the networking team on a once-a-week basis. So now we can actually sit down, go through these reports, look at what some of the top culprits are, and can we solve these problems? And that's kind of our way of solving this. And so these are some of the reports. So here's an example report. So we'll sit down with the networking team. We'll go through all these different reports and seeing, these are the top offenders. Are there areas that we need to look at? So we can kind of look at countries or the ISPs. And then based on what the networking team has seen, and again, I'll show some other slides like digging down into using the Druid cluster, kind of digging down into it, we can kind of do that. So basically, in these meetings that we sit down can go really quick, nothing's really going on, or we go through some of the reports and it's like, okay, there's a lot of bad areas that can we tackle some of these areas. And so that's a real critical way, because when from the Google paper, it kind of mentioned, can we diagnose and can we actually fix some of these problems? And this is the best way we've seen, is actually sitting down with the networking team, working through these issues, and then kind of can we solve these some of these networking problems? Are they ours, or actually do we have to contact other teams as well, or actually outside of our organization? IPv6, very similar report. You got the mobile reports. So a lot of these reports are similar to this. We got the highest culprits, and we can just kind of target which ones we think we can actually tackle and address. So now we may have something we want to address. So this one here is looking at, okay, let's go ahead and look at the traffic we're seeing within a couple of week period. And we noticed, like in this particular issue on, I think it's September 5th, we had an issue in South Korea. There was a big dip. So South Korea was at one of the top ones there. And from the average bandwidth, we see the dip down. So now we can start saying, okay, what is it within the country? What is it? Is there an ISP? Is there a certain ASN that we're seeing problems in? So now you can actually, the nice thing about the pivot on top of this is any of these dimensions that you can grab these things, throw it over there, and immediately it takes seconds to pull up this report. And so now you're basically able to dive into lots of data that's in there in a very quick way to diagnose the issues there. And then the other thing is you have the measurements that you can actually look at. So we're looking at 4 different measurements here. You can add different measurements, and like I said, you can just kind of drag and drop these things. So now we're looking at the country. Let's go ahead and look at South Korea. This is different ISPs. So now we can actually target a couple of different ISPs that we're seeing problems with. Or we can actually look at, like I said, rather than ISP, let's look at it from an ASN level. Now we have a couple of ASNs that we can target. So then the networking team, they can kind of address, do we have is there transit issues here? Can we actually call up some of these ISPs or organizations that were responsible for some of these ASNs? A lot of these times these networking teams have contacts already within these organizations and can immediately solve some of these issues. So then also we have one of the data cubes that we have is for the ATS stats. So now we can actually look at served bytes, but this is by platform. So you see the different properties that we have that we're serving, and who are have the properties with the highest amount of served bytes that we're seeing. I know the ATS team can dig into some of the error codes and stuff with this. And again, it's a mix kind of sometimes, where they go into Splunk or they utilize the pivot. One of the other nice things is the Paranoids team likes going ahead and looking at reports of this. So this one currently tells us the TLS stats. This tells us basically what version is being used in the count of the versions. So when we rolled out TLS 1.3, they can actually look at what's the adoption rate of 1.3. So they can do longer graphs and see how 1.3 is actually increasing and versus 1.2 decreasing. They pull up reports a lot, and they look at some of the like TLS version 1 or 1.1. Can we actually get rid of these things? Or they can actually look at this thing and say, let's pull up which property has the highest use of some of these older protocols. And can we target those properties and say, hey, can you somehow get rid of, if we got rid of TLS 1.0 or TLS 1 or 1.1, what would it do to your clients? I mean, is it going to be an issue? And so kind of they're able to target the different properties and utilize this information. The other thing they can look at is the different ciphers that are being used. So again, any of these components of the dimensions, they can pull up there and start looking at the data. Okay, so how does this help us? So one of the things that the data scientist realizes, like NetFlow data, many of you may be familiar with the NetFlow data. He felt like this data is actually better than NetFlow. It actually has more information in it, and we actually looked at NetFlow. There's some other things we're doing with, we're looking at some other teams with some NetFlow data, but the actual value of the data that we're seeing versus NetFlow has actually been more valuable. So with this, we've been able to fix dozens of network transit issues. Again, working with the network team, they're the primary ones that will go out and reach out to the outside organizations, whether it's internal we need to fix or something outside, they can go ahead and reach out to another team and can we fix this thing? And so basically being able to do that, we've fixed issues for millions of clients. I mean, there are dozens of times where we worked over the last number of years and working with the network team that they can actually solve these things. And we can actually go in there and look at the data and look at what it looked like before, what it looks like now. We can almost target exactly when they fixed this problem. Mm-hmm. Yeah, yeah, basically that's the next point there. It was the same thing, is that a lot of times the network team reaches out and then they're like, oh, we're good, there's no problems here, we don't see anything. But within a day or two, all of a sudden the report's, hey, it's fixed, you know? So somebody realized that yes, there was a problem within an organization. One of the bigger incidents that we've seen is that we're detecting an issue that was affecting around 37 million users, and this is all over mobile IPv6. And so they were seeing some really, really long delay times in there. And there was this, we could actually kind of test in there after working with this organization. We realized there was some issue on their routers where it's like every 60 or 90 seconds, it was resetting something like this, and they would see massive delays. And then so once this problem was fixed, it took quite a long time. Again, same thing. We reached out to this organization. They're like, there's no problem. We don't see this. We're like, we see this. I mean, we triple check to make sure that, you know, if we're going to go to some organization, tell them you got a networking problem, we better make sure that we're right, because they're going to come back and they're a lot of times they're going to be like, you know, hey, there's no problem with our network. It's something on your side. Is there a question? Okay. So yeah, so basically once this was fixed, we saw the median drop from under 100 milliseconds to under 10 milliseconds. And this was affecting 37 million users. And that was within a certain, a main locale. And then once this actually was fixed, we could actually go in there and say, hey, do we see an increase in clients coming back to our network? Do we see, this has kind of popped up a few times since then as well. It's, you know, something may be misconfigured and we can go back and address it as well. So we actually were able to see significant increase in our traffic once this was fixed. Some of the future work we're looking at. So currently, these are being done in a 24-hour kind of batch job. We get all the data in 24 hours, we're creating these reports. We want to get into more real-time, having a real-time data coming in, particularly into the Druid cluster. It's going to provide real-time access for our networking team, so they can just start digging in right away. Within probably 5-minute period, they can start looking at, you know, they know there's a networking problem, go ahead and jump on the Druid cluster using Pivot and start digging into the data, finding out what the issue is. Which is, like I said, it's going to be very helpful for the network ops teams. They're really, really wanting this. Another thing, we were developing a lot of dashboarding. So we looked at something called Superset. Superset is an Apache incubator project, and we're starting to work on developing some of the dashboarding on top of that. We looked at similar things with Grafana and some other tools, but Superset seemed to be the best fit for what we wanted to do. And we also want to replace Pivot with a similar functionality in Superset. So we're looking at getting somebody in to go ahead and write that. And then we also want to be able to allow teams to say, okay, once we have this set up, can we allow teams to come into this data, set up their own dashboarding, so now they can get their own dashboarding, get their own alerting, you know, whenever they want. I kind of mentioned before, BGP collection, that's still kind of future into this. Once we collect the BGP data, we can go ahead and enhance this data with the BGP collection we're going to be doing. That's, like I said, it's been a little bit harder getting that data since it is quite a bit of information that we're collecting. So other analytics projects, these don't go exactly with using ATS logs, but they are also projects that we're working on within our team. We're doing anomaly detection. So on this, as well as other things, other data that we're collecting, we can actually say, are there anomalous things? Can we go ahead and set these alerts to teams? So a lot of times the networking team, can we set up alerts for them? Once they have like dashboarding, they have their real-time digging in with their Pivot into the Druid cluster, the data in there. Can they also start setting alerts to go ahead and alerting them? And then other teams can kind of set this as well. We're doing a multi-CDN measurement project. So this is basically doing beaconing across different CDNs. We have our CDN, other CDNs that we utilize, and we can actually do some beaconing and look at how does our CDN compare to other CDNs. It's a very useful project as well. There's some different teams that are already utilizing some of that data within the organization. And then I mentioned BGP collection as well. So once we have the BGP data, again, the networking team is really hot on us doing this, but it's been particularly challenging for quite a while to get all the data in that we need. We have a lot of POCs that are running. We get data in right now. We're starting to look at some of the dashboarding. We had an intern over the summer, built some dashboarding looking at the BGP data, but actually getting the full BGP data in a real-time fashion, it's been a challenge. We're close. By the end of this year, we should have it. I think that's it. All right, it's kind of quick. Any questions? Yep.
You mentioned you're able to gather the browser version. Do you have a user agent parser or something that you use, or how do you do that? How do you get the browser version?
The browser version?
Yeah.
The logs,
Yes.
and then there is.
Oh, so
Yes.
you do it inline. You do it on ATS. But you do it inline, like in ATS or offline?
No, it's, well, we can.
Yeah, it's an ATS. Yeah, we have an ATS plugin in line. It's called device classification that classifies the devices attached to it. So we get all that information in there.
That's a lot of regexes, I'm assuming.
It's on too.
That parsing is a lot of regexes, I'm assuming, right? I mean, user agent parser is.
I think we have a
Big
database
tables.
that.
Okay. I mean, if you're going to the level of version, I mean, it's tons of regexes in general. I don't know how fine you get the mapping, but okay, just curious. And the other question I had was, you mentioned anomaly detection. Are you also thinking about doing something related to correlating that to any change in the system, entire end-to-end system?
We are, particularly around the BGP data. That's going to be a lot is like, how if BGP tables are updating and the changes in the updates, and that will tell the network team a lot. Is somebody hijacking a BGP prefix? Are we seeing some of that?
Okay.
That's probably the first one we're going to tackle in that area there.
So you're scoping that just to the BGP-related anomalies?
Initially, yeah. So
Okay.
the initial one. We might expand that. Again, the current data analytics team is made up of 3 people. So. And one of them is actually leaving, so we're down to 2 people. So we're kind of tight right now. So we're kind of limiting as what we can do, but what we want to do, yeah, there's a lot of stuff we'd like to do.
Okay, yeah, because with ATS access logs being at the edge, you should be able to detect anomalies and correlate that to changes outside of BGP, meaning within your ecosystem. It's very interesting. Actually, you get the full picture of the entire stack
Yeah.
because you're at the edge.
Okay.
Very good to know that.
Yep. Do you have a question, Alan?
Hi. Do you also collect information at layers way below HTTP, like, for example, to detect SYN floods or similar attacks?
We do not. I mean, the lowest stuff that we're collecting is like doing the RTT measurements on the server, collecting that at that level. I know there's some teams within Verizon Media that are doing more of that, but we have not.
So that information is not in the analytics system?
Which stuff?
The information that the other team is using in order to detect?
Not into
SYN.
ours. Yeah,
Okay.
they have their own system that they're doing some analytics on. So we've talked with them about being able to do some integration. But it's probably long-term off to doing that.
Thanks.
Anything else?
So can you talk a little bit about how you chose median round trip time versus something like 95th percentile or something bigger, smaller?
I'd probably have to ask our data scientist what he did on that. I don't know if anybody else has any insight into the history of that.
You mean in terms of what we're displaying, or?
So
or
round trip
for-
times will have a big variance, and so choosing which kind of measurement you look at is an interesting choice.
Yeah,
Right?
I
Because
mean,
it could be like the fastest, or are you looking for the fastest, or are you looking for the median, or like what's?
yeah, I mean, yeah, we right. Yeah, I mean, we collect all the round trip times, and yeah, there are analyses that do look at the percentiles. So
Yeah,
All the things.
Yeah, we do have some reports that do that. We haven't utilized those reports as much, but occasionally we'll pull those out and look at what does it look like at the 90th, 95th, 99th, and so forth.
And then DNS IP versus client IP. So ATS only sees the client IP, but not the DNS IP. How are you thinking about grabbing the DNS IP and round trip times and stuff like that?
Yeah, it's something we're looking into now. I mean, right now, we'd actually, some of the info we can get back through EDNS 0 information, and then we're kind of looking at now if you have DNS over HTTPS, it's like what's that going to affect us? So we're actually, data scientists are running some kind of experiments now looking at can we find out some of that information, and it may get much more difficult in the future because of some of these things. Something we're looking into, but yeah, right now we can just do best estimate of the information that we have. Anything else? All right, thanks.